Good morning. This video is to talk about the questions you guys left me in the Google form on homework number 7. And so I had a couple of questions about problem number 3. So problem number 3 tells you that a first-year teacher will make $12,000 with an annual raise of $1,150. And this is obviously an outdated question. Teachers make more than $12,000. So the first part says, how many years will they take them to reach the maximum salary? So you're wanting to know how many years, so that would be N for 28,000. So the first thing I did is I wrote this in point slope form. So A of N minus 12,000 will equal your rate of change times N minus 1. And I know A sub N has a value of 28,000. I'm trying to find the number of years. So I subtract, then I divided by 1,150. Notice I actually am getting a decimal here, and we'll talk more about that in a second. And so then my final answer is 14.913 years. So here's one thing you have to understand about annual salary. When you get your salary, you get it on day 1 of a year, and that salary is the same salary for the entire year. So when you get 14.9, it's not the fact that in the middle of the year, in October, you all of a sudden get bumped up in your salary. No. During year 14, you're going to make a set amount that entire year. So what this means then is in the 15th year, that at the beginning of year 15 is when your salary will increase to the 28,000. At the beginning of year 14, you were not making 28,000. Okay, so I want to make sure you understand that. I had another question. Can you use the recursive formula? Sure. I mean, you certainly can take a term. You certainly can take 12,000 and add 1,150, and then take that amount and add 1,150. You certainly can do that. And then someone said on the recursive formula, you add, why do you multiply here? Well, here's what you have to remember. This is really rate of change. So this is saying for every new term, you're adding another 1,150 to the first term. This is like slope. Remember, this formula is saying to the previous one, you're going to add 1,150. So you're not really doing a different mathematical operation. Okay, this is slope. So when N increases by 1, your Y value increases by 1,150. Okay, hopefully that answered that question. The next one that I have received a couple of questions about, let's look at number 10. And I think it's the answer on the back is why you guys were asking questions here. And so as I look at number 10, it tells me it's arithmetic. So I need to find the common difference, the rate of change, the slope, whatever you would like to call that. And so when you find that up and you set this up, I get 102 over 17. So I find the common difference to be 6. I need to write the explicit formula, and I can use either of the points that I have created here. So I'm going to use 1050. A sub N minus 50 will equal 6 times N minus 10. Now, I had a few of you say the answer on the back didn't look like that. Well, look at the answer on the back. What has happened on the answer on the back is that A sub N is by itself. So it's really solving for A sub N. So I'm going to add 50 and go ahead and distribute. And so when I combine my like terms, I get 6N minus 10. If this were on a regular something, I would certainly accept this answer. One of the things that's good about your homework and trying to match the answer on the back is if this were a multiple choice question, maybe this is the multiple choice answer that's correct. Your answer may look different, but you have to be able to manipulate it. For the recursive formula, you can certainly say A of 10 is 50, and then to get A sub n, I'm taking A sub n minus 1, and I'm adding 6 to it. But if I look at the answer on the back didn't use A10 equals 50. It said A1 equals -4. So to get the answer on the back, we went back and found the first term, and we can double check that. If you plug 1 in here, you do get -4. So again, we're just trying to make those answers match up. I had a couple people ask about number 12. So this is about a lottery here. So the first ticket wins, let me do it like this, $10,000. It says that each successive winner receives $500 less. So that's our common difference. How much does the 10th winner receive? So once again, we can write this explicit formula by using point slope form. And for our first problem, we want to know how much does the 10th winner receive. And I would just solve this equation, and when I do, and you guys can solve that, I get 5,550. The next question is, how many winners will there be? Well, now you got to think a little bit carefully here. If you have $10,000 and you need to give away $10,000, and every time it's decreasing by 5,000, what amount will your last winner receive? Your last winner will receive $500. I could see how some of you might have said 0. Well, if you receive no money, are you considered a winner? So the last winner will receive $500, and so I need to find n for that. So I'm going to plug in 500 minus 10,000 equals -500, your slope rate of change, n minus 1. And so when I solve that, I do get 20. So someone asked, why is the answer not 21? Well, actually the 21st person, there is no money left for that person. So I wouldn't consider that to be a winner. A couple people ask about both 18 and 19, and these problems are very similar in that they are geometric, and you're trying to find n. So if I look at 19, and 18 is worked the exact same way, I can write the explicit formula. A sub n will equal, my first term is 1. I can see r is 3. And since I used the first term, my exponent is n minus 1. I'm trying to find which term is 19,683. So unfortunately, until we learn about what's called logarithms next semester, you're really going to have to kind of do a guess and check here. And so what I did is I tried to write 19,683 as 3 to the something. Because if my bases are the same, the exponents have to equal each other. So let's just test out a few. So what is 3 to the 5th? Well, not quite enough. 3 to the 6th, 3 to the 7th, I'm getting closer, 3 to the 8th, 3 to the 9th, and there I have it. So I could write 19,683 as 3 to the 9th. If the bases are the same, the exponents do have to equal each other, and so therefore I get n is 10. And then let's look at 17. So 17 gives us a geometric formula, sequence, and says write the formula. Well, I can see here that r is 1/3. So a sub n will equal 54 times 1/3 to the n minus 1. There's your explicit formula. Recursive, I need some term to start multiplying by 1/3. It doesn't have to be a1 is 54, but that's just the easiest to use at this point. And then recursive is always saying, what am I doing to the previous term to get the term I'm looking for? Well, here I'm multiplying by 1/3. And it does say find a sub 9. That would certainly be a calculator problem where you can just plug 9 in. But I think whoever was asking about the two types of equations.